In this example, I'm going to use Newton-Raphson's again to try and find the point of intersection between these two functions. You can see that I've drawn the sine x function, and the other function is the hyperbola of 1 over x. And I want to see what is the point where these two functions intersect. Now, if I write this as sine x minus 1 all over x is equal to 0, I will be able to use Newton-Raphson's because the expression that I'm going to be using is sine x minus 1 all over x. Let's start. The first thing that I need to do is I need to figure out an interval that I'm going to be working on. Now, as I have a trigonometric function, I'm going to be working in radians. We know that at the turning point of the sine graph, over here, we're going to have that it turns at pi all over 2. In other words, that point of intersection was somewhere between when x was 0 and x was pi over 2. So the interval that I want to work on is going to be between 0 and pi over 2. Now, pi over 2 sometimes may seem a little bit distant and difficult to work with, so work it out as a decimal fraction. Pi over 2 as a decimal is 1,5707. So if I want to make my first estimate, it must be somewhere between these two numbers. And I'm going to say, make my first estimate as 0,75. In order to set up my equation, I'm going to make sure, first of all, that I find the derivative of that function. So if my function is going to be f of x, then the derivative of my function must be the derivative of sine of x, and we know that that is cos x. And it must be the derivative of minus x to the minus 1. And if I do the derivative and make it with a positive exponent, I find that the derivative of 1 all over x is going to be 1 all over x squared. I'm now ready to set up my equation. Remember, I'm looking for the second estimate. I find the second estimate by using my first estimate minus my function with the first estimate all over the derivative of my function with that same first estimate. Writing this out so that I know how to put it into my calculator easily, I'm going to get my second estimate by taking my first estimate. Remember, we said that was 0,75. And then I say, what is my original function? That's going to be sine at my first estimate minus 1 all over my first estimate. That is the numerator part. Now for the denominator, I'm going to put in cos of my first estimate plus 1 all over my first estimate squared. Remember, our first estimate must be put into your calculator initially. So you need to type the estimate of 0,75 into your calculator. And then you need to press equals and answer. Then press minus. Put in a fraction. Type sine, answer. Close your bracket. Then minus. Make another fraction. In the numerator, write 1. And then in the denominator, type answer. Go into the denominator of your big fraction, type in cos, answer, close bracket, then plus, put in another fraction. In the numerator, a 1. In the denominator, type answer squared. Now remember, your calculator does the rest. Keep on pressing the equal sign over and over and over again until you find that your decimal digits stop changing, and then you would have had your final answer. In this case, the final answer, where these two graphs crossed each other, was exactly when x was 1,1142 radians.